Hey guys, this video is for Calculus BC and it's a continuation of 6.1. It is called Euler's method. Okay, so this man Euler created a method that would give an estimation of what a differential equation gives you. Again, a differential equation is just doing the antiderivative of a function that has both x's and y's. Okay, so the question will always start off by giving you an ordered pair, and that's called your initial condition. Okay, that's what you're going to start off with. They're also going to give a delta x, the amount that they want you to change in each step you take for your delta, on your x's. Okay, notice I draw an arrow because that delta x is going to be the same throughout your question. Okay, so those three are given. Then step 2 here says that they're going to give you an equation for dy dx. Okay, you're going to plug in your x, y, and delta x into that equation to solve for this spot. Okay, now if delta y over delta x is the same as saying dy over dx, I can multiply that delta x over to isolate delta y, which is why solving for delta y is just multiplying these two answers here, your delta x, which was given, and the dy dx that you just solved for. Okay, once you get to that step on your chart, you're going to use this delta x and delta y, right, your changes in x and y, to get to your new ordered pair. Okay, once you get to that new ordered pair, okay, so we just said step 4, you're going to repeat the process until you obtain the y value being asked. So the way they'll ask you that is they'll say, use these points in order to find out what y is when x is, and then they'll give you some number like 7. So you keep changing in your x's until you get to x is 7, and you find out what y value that will give you. Okay. If for whatever reason your delta x goes in the negative version, okay, so it says here to create the table moving to the left from the given initial condition, use a negative delta x. So let's say they gave you 2, 3, and they want you to go to negative 2 to a smaller x, then you just use a negative delta x. Okay, and again, your Euler's method is an estimation process of this differential equation. Let's take a look at this first question. It says, use Euler's method with increments of delta x being 0.1. So the first thing I can do is fill that in right here in the chart where delta x is. So I'm going to say 0.1, and that's going to run true for the whole question. Okay, you could either draw an arrow or rewrite it every time. And we're going to use that to approximate the value of y when x is 1.5. So we're going to have to go all the way down until we get to 1.5. Given that dy dx is x plus 1, so every time I solve this, I'm going to be plugging x into x plus 1 when y is 2 and x is 1. So there's my first ordered pair. Okay, so like we said, those three would be given, and now we need to start solving. Now, if I'm incrementing my x's, there's certain things you can take in a different order. So if I'm incrementing my x's by 0.1, I know that this is going to go from 1 to 1.1, 1.2, 1.3, 1.4, and then 1.5. I'm going to stop here at 1.5 because they asked me to solve for y when x is 1.5, which means when I get to this part in my chart, I'm done, and that's going to be my answer. It's the y value when x is 1.5. Okay? So now the next thing I can start doing is saying, okay, let's go horizontally. If dy dx is x plus 1, and here x is 1, well then 1 plus 1 is 2. Okay? Dy dx is these two answers multiplied, my delta x times my dy dx. So feel free to take out your calculators for this, okay, guys? But do recognize that a lot of times these questions might not be in the calculator section of the AP test, okay? So know that the algebra and the arithmetic won't be too crazy. So 2 times 0.1 is 0.2. So now my change in y is going to be by 0.2. So 2 plus a 0.2 is 2.2. You cannot go all the way down the chart because my change in y will be different every time, unlike my change in x. Okay, let's keep on. Dy dx here is going to be x plus 1. So 1.1 plus 1 is going to be 2.1. Now for delta y, multiply these two. 0.1 times 2.1 is going to be 0.21. We multiply this by 1, but now there's one decimal point and another, so we have a total of 2, okay? My change in y is 0.21. We add that to 1.2, and we get 2.41. Moving on. Delta x is my x plus 1. I have 1.2, so now I end up with 2.2. To get delta y, I multiply these two. 2.2 times 0.1. Anything times 1 is itself, but now I have two spots of decimals, so I'm going to move that over twice. 0.22. That's my change in y. I'm going to add that to my previous y, and I get 2.63. Okay, we're starting to get closer. Next row, plug my x into my into my dy dx. So I have 1.3 plus 1, so I have 2.3. Delta y is my delta x times my dy dx. Anything times 1 is itself, but I have two decimal points, so I have 0.23. That is my change in y, so that's how much I'm going to change in my y here. I'm going to add them, and I end up with 2.86. One more time, guys, almost there. Now we can say that my dy dx is x plus 1, so 1.4 plus 1, I get 2.4. For my delta y, I'm going to multiply these two. Anything times 1 is itself, but I have two decimal places here, okay? So I'm going to have 0.24. And now my change in y added to the previous y, and I end up with 3.1. So I can say that by Euler's, f of 1.5 is approximately, because remember we're using this as an estimation, 3.1. And that's how you would answer that if it was a FRQ, a free response question. This next question reads, use Euler's method to estimate f of 2. So we're going to find the y value when x is 2 with a step. So instead of using the term delta x, they said a step of 1 over 4. Okay? 1 over 4 as a decimal is 0.25. Whoops. Okay, and that's going to be the same the whole way down. Okay? Now, I turn it into a decimal because as I start working the rest, I usually get some big decimals here. So this is going to be a bit easier. Okay? And then they say when dy dx is 2x squared over y. Sorry, guys, my handwriting's a little off today. So 2x squared over y is what I'm going to be plugging in to get these. And then if we start off at f of 1 is 5, so that means my x is 1 and my y is 5. So if my delta x, my x is constantly changing by 0.25, I want to get up to the number 2. So I'm going to go to 1.25, 1.50 or 1.5, 1.75, and then 2, okay? So I don't have to worry about the rest of the chart. My answer is going to be right here. So I can stop when I get to this point. So let's move on down. If I'm plugging x and y into my dy dx, okay, I have 1 squared times 2 divided by 5. I end up with 0.4, okay? Now, I'm going to multiply these two together. 0.25 times 0.4. Multiply the 25 and the 4, and I get 100. But I'm going to have my decimal places moved 3 over. So I end up with 0.100, or technically 0.1, okay? So now that's my change in y. So 5 plus 0.1 is 5.1. 0.1. Okay? Now plug that x and y in here. When I clean that out, you're going to need a calculator for this one. It's 0.6127. Multiply these two together, and I get 0.1531. That is my change in y. I'm going to add that here, and I'm going to end up with 5.2531. Now that I have my x and y, plug that into my dy dx, and you end up with 0.8566. For my change in y, multiply my delta x and my dy dx, and I end up with 0.2141. That's my change in y, so I'm going to add that here. I end up with 5.467. Okay. Now that I have my x and my y, plug that in here to get my dy dx. I end up with 1.1203. Delta y, multiply the delta x and the dy dx. So 0.25 times this number gets me 0.8007. And then that's my delta y, my change in y. I'm going to add that to this number, and I end up with 5.747. So I don't need to keep going on this chart. I can say that by Euler's, I can say that f of 2 is approximately 5.747. And that's it.